So now let's talk through step one. We know that this is the step where we are stating our hypotheses. And as always, there's two of them, an alternate and a null hypothesis. And as always, the null predicts there will be no differences. The treatment will not do anything at all. The groups will be the same as each other. And the alternate hypothesis, of course, says, of course, the treatment works, and those groups are going to end up different from each other. That 10 milligrams of a medicine is going to be different than 20, or that 0 is going to be different than 10. The complexity here is that if we've got three different treatment conditions, again, going through the same example, 0, 10, and 20 milligrams of a medication, well, which groups specifically for my alternate hypothesis am I predicting are going to be different from which other groups? I could predict that 1 and 2 will be the same but different than 3. I could predict that 2 and 3 will be the same but different than 1. Right? I can have all these different combinations. They're all different from each other, or only 1 is different from the other 2, or only 2 is different than the other 2, or only group 3 is different. That's a lot of different hypotheses to try to manage. So what we're going to do is simplify, which oddly in our remote classroom situation is almost easier in terms of your quizzes and exams, because we're going to write this in English. This isn't a remote concession. This is the way I would teach it even if we were live. So the alternate hypothesis is at least one treated population mean will be different from another treated population mean. So all we're saying here, in really the most broad catch-all way possible, is at least one of the groups will be different from the others. Maybe they'll all be different from each other. We don't know which group, and we don't know which combination of groups, but this will cover everything. It's important that you include the entire sentence. You must include the entire sentence. You can't stop at just the top. At least one treated population mean will be different. Whenever you are making a comparative statement, and this isn't just statistics, this is just good, educated grammar. Whenever you're making a comparison, this will be different than that. You have to say what you're comparing it to. I often think about when I'm talking about this, one of my least favorite commercials in the history of commercials, and I hate most of them, but for Diet Dr. Pepper. And their catchphrase, if you will, their advertising slogan for a long time has been, Diet Dr. Pepper tastes more like regular Dr. Pepper, period. Tastes more like regular Dr. Pepper than what? Than Sprite? It ought to. Than the water in my dog's water bowl? I hope it tastes different than that. Tastes more like regular Dr. Pepper. If you don't finish the comparison, you're really not saying anything. So we have to include the whole sentence to say, what are we comparing? What are the elements in play? So that's it. That's the only way to write it. That's this chapter and next chapter. Chapter 13, this will still be how we're writing it because we'll still be being ANOVAs. So this will be exactly word for word like this for the next couple of chapters. For our null hypothesis, we can go back to our regular format of symbols. Or, again, some of you are preferring writing it in English language. That's fine too. But in symbols, remember the null says that the treatment won't have any effect, so all the groups will be the same. So here the null hypothesis is treated population mean 1 will equal treated population mean 2, which will equal treated population mean 3. So a lot of you have really got the hang of finding those symbols. Type it like that. Or again, translate it all into English. Treated population mean 1 will equal treated population mean 2, which will equal treated population mean 3. That's how we're going to put it, either in the symbols or with that sentence structure. So make sure it's exactly like that to get your full credit. So, and that also will be exactly the same every ANOVA we do. So both this chapter and next chapter, this is it. Step 1 is done for 2 weeks. That's the only thing we can and will be writing for credit. So next up, off to step 2 in the next video.